All right, y'all. So 2.3 will deal with, like I said, finding domain and range. So we'll start looking at graphs for domain and range, and then we'll learn how to find domain and range of a function. Okay, so first let's find out what is a domain and range. So your domain, that's going to be the set of all x values for the graph. Okay, now you can look at your domain as the inputs of a function. Okay, so these are all the numbers you're going to be putting in for the variables and all that fun stuff, okay? So those are your x values. And then your range, that's going to be the set of all y values for the graph. And you can look at these as the outputs of a function. So I'll put a x value in, I get a y value out of it, okay? So y'all, the first thing of all, they want us to look at a graph and answer a few questions. So I'm going to put a graph up here. And y'all, here's my points. So it looks like we got 7 points on here, okay? So for the graph, for part A, let me pull this down a little bit. For part A, they want you to find f of -1. All right, so remember, when they tell you to find a function value and they give you so they're telling me, when they put a -1 in there, they're telling me that the x equals -1. So they want me to find the y value that corresponds to an x value of -1. All right, y'all, so we go to our graph. Here's the center. So go left to -1. So we're wanting to go straight up, 1, 2, 3, 4, 5. So that means f of -1 equals 5, since 5 is the y value of that point. So f of -1 would equal a +5. All right, y'all, for B, they want us to find the domain. Now on the domain, they're going to give you the little squiggly curvy parentheses. And all we got to do is put in all those x values separated by a comma. So y'all want to look here to my first point. I'm just going to go left to right on them. So my left point, if I come straight down, looks like it's hitting at -5 here. So -5 would be my first x value. And then coming down from the next point, it has an x value of -4. So all we're doing is finding our points and coming down and getting them x values. That's -3. My next point coming straight down is at -2 on the x's. My fifth point coming down is at -1. All right, this point is on the y-axis, so of course it's going to have an x value of 0. And then my last point here, if I come down, has an x value of 1. So you're going to go through your 7 points and looking for only the x values since all they wanted was the domain. So you can treat this x-axis as your domains here, okay? These are going to be the domain values. All right, y'all, then they had a C here. So for C, they want me to find any x values for which f of x um, equals 7. So it's so look here, it's similar to this problem. But here they gave me the x value, I found the y value. On this one, they're giving me the y value and they want me to find the x values that have a y value of 7. So remember, this here is my y equals 7, okay? So I would look up here and find 7 on my y-axis and see what points were on that line. So let's go. 1, 2, 3, 4, 5, 6. 7 is right here. So I'm looking for any points on this line. And I got 2 of them. So the first one is this point. So I'm going to go straight down. And it had a value of -5. So that would be x equals -5. And then y'all, we had this point that had a value of 7. So coming straight down, that one had an x value of 1. So look at this. A, they gave you the x, you found the y. C, they're giving you the y and you're finding the x's on it, okay? And then y'all, last thing they want is the range. And remember, the range is the set of all y values. So y values go up and down. So I'm going to find the smallest point here and come straight across. It looks like that has a y value of 1, 2, 3, 4 here. So 4 is my smallest y value. And then coming up, the next 2 points have a y value of 5. So since 2 points share that value, we don't have to write the value but once. Same thing here. 2 points are sharing this value of 6. And then, of course, we know these 2 points were sharing a value of 7. So on this graph, you're just getting familiar with the domain and range. The domain is my x's and the range is my y values, okay? All right, y'all. Now, the same thing we're going to do to this next one. The only difference is they're giving us a graph of lines. So, and these lines go on forever in each direction. Okay? Alrighty. But they're going to ask me the same 4 questions on this number 2. For A, they want to find f of 3. All right, so remember, they're telling me the x equals 3 on this one. So since the x equals 3, I'm looking for the y value that corresponds to x equals 3. So y'all, what would y'all put on that one? Hey, y'all, that's perfect because here's 3, right? We go straight up, and that intersects that y equals 2 line. So definitely f of 3 equals 2. All right, now this one's going to be a little trickier on the domain. And so I'll sort of help us on this one. Notice the axis right here is for my domain, right? Well, this graph is going forever in the right direction. It's heading off towards what we would call positive infinity on these x's. And over here, these x's, this graph is going left as far as it can. And this side is headed off towards negative infinity. When you got a solid graph like this, heading off in both directions on that x-axis, we say that that domain is all real numbers. Because, it's covering every point in between 5 and 6, 6 and 7, and so on. So when your graph goes in both directions forever, your domain will be all real numbers. Now, later on, we'll learn how to rewrite this. Um, in the future, we'll rewrite all real numbers like negative infinity to infinity. Okay, but for now, we're not learning that part, so they're just going to write it out. All right, y'all, look at this one. Any x values for which f of x equals 2. So it's going to be x equals blah, blah. Remember, they're giving me the y value here. They're telling me the y value is 2. So they want me to find the x's that have a y value of 2. So, here's 2 right here. So we got this point. Well, that had an x value of, what's that, 3? Well, we knew that one would be there because remember, a while ago, f of 3 equaled 2. So now they're giving me the 2 and I'm finding the x, which was 3. But look here, there's also another point right here. This point, if I come straight down, looks like that has a x value of 7. Okay, so remember, A and C are sort of opposites of each other. A, we give you the x, you find the y. C, I give you the y, and you find me the x's. And then y'all, of course, D wants the range. Now remember, the range is the y values here. So the question is, could I put all real numbers for the range? And if you look at that thing, my y values are only in the positive direction. I don't have any y values down here on the negative side of the y values, right? So the y's can't be negative on this one. So what we're going to say on this one is, and remember, the range is the y value, so you use your y. So how could we write this? So what's the smallest y value we see here? If you're on that x-axis, what is that y value? All right, Ben, that is 0, right? So that means since my lowest value is 0 and the y values are increasing, then we would put something like this. The range is the y values. Now this little bar means such that. So y such that y has to be greater than or equal to 0. So it equals 0 here, and then it can be anything greater. But it cannot include any negative y values. So y'all, that's looking at a graph and finding your domain and range. So now what we want to do is look at functions. How to find the domain and range of a function, okay? Now, here's one thing we got to remember. The domain can only include values that produce real number outputs or Y values. Okay, so any number in my domain, I'm going to be able to plug it into my function and get a real number out of it. Okay, what I got to exclude from the domain are any numbers that are not real. And at this point with us, the only numbers we're going to be concerned with are numbers that make things undefined. Okay? So we must exclude any values which make a fraction undefined. So remember, any number divided by zero is undefined. And you can't plot a y value that is undefined. Okay? So my domain can include all numbers except numbers that make a fraction undefined. So that means we're only concerned with functions. So we are only concerned with functions that are composed of fractions. Okay? For any other function, the domain is all real numbers. All right, so in this section, they use this set builder notation. And that's going to be, you're going to be given them fancy little curvy parentheses. You name the variable. So this tells the variable. This bar, remember, means such that. So we're saying that our domain consists of the x variable such that, and then you put your condition. So you would say something like x is a real number. So if it was all real numbers, I would stop there. But if I do got to exclude a number, I would write something like this. X is a real number and x cannot equal whatever number I figured out. So if I had a fraction with the zero on the bottom, when I put in for the x's, right here I would say x is a real number and x cannot equal zero. So whatever number makes that denominator a zero, we're going to exclude, okay? So, so to find any numbers that must be excluded from the domain. So the only thing I'm going to do to find any numbers to be excluded from my domain is I'm going to set the denominator of the fraction equal to 0. So you're forcing it to give you the numbers that make it equal 0 by setting it equal to 0. So you're going to set that denominator equal to 0, solve for the variable. Once we solve for that variable, we're going to exclude any of the solutions. So if I get one number for that, I'm going to exclude one number. Later on in life, when we get more into the quadratic stuff, we'll be excluding two numbers from our domain. But y'all, that's it. Excluding any of the solutions, right? In set builder notation. Now, thanks for y'all in this section. Most of them are A, B, C, D for you, okay? Hey, y'all, so I'm only worried about fractions in my functions. If my function does not composed of a fraction, then my domain will be all real numbers. Any number I put in will get me an output for it, okay? So they're going to say find the domain. Alrighty, so I got f of x equals 2 over x minus 11. So I do have a fraction, which means I got a variable in my denominator. So since I got a variable in my denominator, it's possible that there are x values that'll make that thing equal 0. So to find it, we're going to set x minus 11 equal to 0. Now y'all remember, we're not concerned about the top of a fraction. The top of a fraction can be 0. It's the bottom that can't be 0, okay? All right, y'all, so let's solve this. Move 11 over by adding. So I get x equals 11. So that means if I put 11 in here, 11 minus 11 is 0, which makes that undefined. And that is not a real number output, okay? So we're going to kick that 11 out of our domain. So x such that x is a real number and x cannot equal 11. So make sure you're picking the ones that's got the not equals on them, okay? Alrighty, y'all. So that's how you're going to find a domain, and we're only concerned with fractions. So any questions on that one? All right, same thing on this one. So this one's on y'all guys, okay? Find me the domain of P of x equals 2x minus 3. Any ideas what that domain will be? Oh, got y'all early today, right? So let me ask y'all this. Do y'all see a fraction there? There is no fraction here. And we said a while ago, if the function, where'd I go? For any other function, the domain is all real numbers. Y'all, that's our domain on this one. My domain will be x such that x is a real number. Okay, so how about 5? 5, they're giving me p of x equals x squared plus 4. Once again, I do not have a fraction, so my domain is all real numbers. Any number you give me, I can put it in here and square it and then add 4 to it, and I'll get a real number. Okay? So since there's no fractions, x such that x is a real number. All right, y'all, let's see what they got left. Two more of these. But what I'm looking for are fractions if I'm going to exclude any numbers, okay? So let me see what they're doing on 6 here. On 6, they're giving me g of x equals 3 over 2 minus 7x. So you knew they're going to give me more than one fraction on these, right? So here's my second fraction. So it's possible that that denominator could equal 0 because there's a variable right there. So once again, we're going to set that denominator 2 minus 7x equal to 0. And then we're going to solve this. So on this one, y'all, we're going to move the 2 over by subtracting. So those 2's cancel. I get negative 7x equals a negative 2. And then we're going to divide both sides by negative 7 to make that a 1x. So that'll equal negative 2 over negative 7. So negative divided by negative makes that a positive 1x. And then negative divided by negative makes that a positive 2/7. So for this one, our domain, x such that x is a real number and x cannot equal 2/7. All right, y'all, so this is the last one. I'm going to let y'all answer this one. You got p of x equals absolute value of x minus 10. So the question, would you exclude any numbers from that domain or would it be all real numbers? All right, y'all, definitely all real numbers because there's not a fraction and you can take the absolute value of any number, okay? So good job. This would be x such that x is a real number. And I did have one more. I thought I was done, but there was one more. P of x equals x cubed minus 10. And y'all, basically, that's the same thing, right? Any number you give me, I can cube it, multiply it by itself 3 times, and then subtract 10. So this is be the same thing as that, right? It's going to be all real numbers. And y'all, I'm wanting y'all to see that on these domains, at this point in life, we're only concerned with fractions, okay? Fractions are the only thing will kick a number out of our domain. All righty, y'all. So now we can step into 2.4. Now, 2.4 does the algebra of functions. So if you like algebra, this is your section. This is the algebra of functions. All right, so there's four operations we'll be doing. We'll be doing f plus g of x. So y'all, when I see f plus g of x, they want me to take my f of x and add my g of x to it. When you're adding two functions, the only thing we can do is combine like terms. Okay? Combine like terms is all you can do when you're adding. Well, the next one would be f minus g of x. That's going to be f of x minus g of x. It's similar to adding, but we got to do one thing first. Our functions are going to be in parentheses, so we have to distribute the subtraction through the second function. So distribute the subtraction through the second parentheses. Then I can combine like terms. So adding, you can drop the parentheses and just add like terms. Subtraction, you got to distribute that subtraction through the second parentheses. And then once we're done with that, combine like terms. All right, then we get into f times g of x. That's going to be your f of x times your g of x. So you're multiplying. So recall, when you're multiplying x to the a times x to the b equals x to the a plus b. When you multiply x's times x's, you add those exponents. Now, multiplying might consist of distributive property. It could consist of foiling. Okay? So depending on what I got, I could be distributing or I could be foiling if I got two things times two things, okay? And then we got f divided by g of x. That's going to be your f of x divided by your g of x. So since we learned domain stuff, what can g of x not equal? What do y'all think? What can a g of x not equal on the bottom of that fraction? All right, good job, y'all. G of x Cannot equal 0. Now, we don't do a lot of stuff with the division. It's going to focus mainly on the adding, subtracting, and the multiplying, okay? So, y'all, let me show you how these examples will go. So, this first one says, given f of x equals x squared plus 2, g of x equals x minus 1. They want me to find f plus g of x. So this is what they want me to find. So I'm going to start out with that. I'm going to do f plus g of x is going to equal my f plus my g. So f, they gave me x squared plus 2. G, they gave me x minus 1. So start out with parentheses on these. Now, since this one's being added, I can drop all the parentheses and all these variables and numbers will stay the same sign. So that's going to stay at x squared plus 2. This will stay at x that's positive, and that'll stay -1 for the number. Can you go any further on this one? Because remember, now we're just trying to simplify it. And we said up here on adding, y'all want to combine like terms. So Jada, good job. Because remember, we're going to combine like terms, and I do have some like terms there. All righty now. Remember, when you combine like terms, y'all, you are not allowed to change the way your variables look when you add like terms. So the only like terms here are the 2 and the -1. So this x squared will come down. This x will come down. I'm just putting them in what we call descending order. And then the 2 and the -1 give me a +1. There you go. Now, y'all are getting x cubes there. Now, let me ask y'all this. This x squared is not being multiplied by that x. The only way you can change these variables, y'all, is by multiplying like we did here. X squared times x would be an x cubed. But we don't have no multiplying going on. So remember, when you're adding, x squareds only add to x squareds. X's only add to x's. Numbers only add to numbers, okay? So y'all remember that. X squareds and x's do not add, so you just got to put them in order. All right, so this one they're saying given f of x equals x squared minus 4, g of x equals x plus 1. They want me to find f times g of x. Now they're using a dot for multiplying in here, but actually I could just do fg of x and put my f and g right next to each other. That would also imply multiplying, okay? All right, so we're multiplying. So we're going to have f times g of x equals my f times my g. So I'm putting these parentheses right next together to imply multiplication. Let's put f in. That's x squared minus 4. And then g was x plus 1. So y'all, this is where we taught y'all when y'all had two things times two things. This is where we did the foiling stuff. So y'all watch this. So foiling is the first one from the first parentheses times the first one in the second. So that means the first ones get multiplied. So let me ask y'all this. Here's the x squared times the x. What would y'all put on that? Now, Ben, is when I'm going to put that x cubed. Good job. So that's going to give me the x cubed. All right, then you'll take the outermost. Well, the outermost is the x squared times 1. And x squared times 1 is x squared. So see, the F and the O, they basically want you to distribute the x squared into the second parentheses. Now the I is the innermost. So the I is the negative 4 times x, which is the negative 4x. And then the L is the last one from the first parenthesis times the last one from the second parenthesis. So that's negative 4 times 1, which is negative 4. So basically, you distribute the x squared and then you distribute the negative 4. So, could y'all go further on this one if you were simplifying? So that would mean, do I have any like terms? And y'all are saying no, so good job. Because x cubes, x squareds, x's and numbers, none of them add together, y'all. So that would be the final answer for that. Okay? All right, let me give y'all some more of these. All right, y'all watch this one. Given f of x equals x squared plus 1, g of x equals x minus 2, find g times g of x. So a little curveball here. So we're finding g times g of x. So since I'm multiplying, I'm going to put my two parentheses right next together. So it looks like we're going to FOIL again. But what I want to know is what's going in the first parentheses and what's going in the second parentheses. So let's start with the first parentheses. What would y'all put in the first parentheses? All right, x minus 2. Good job, Ben, because that's g. All right, so Ben, if you're putting x minus 2 in the first parentheses, what are you putting in the second parentheses? Same thing, y'all. Good job. So this is where math tries to get tricky. They gave you an f of x, but guess what? We don't even have the f of x in our problem, right? So they're just throwing you a little curveball. So g by g is the same thing multiplied times itself. So two more things times two more things. So once again, we get the FOIL. All right, y'all, here we go. We got an x times x. Now remember, that's a 1 plus 1, which gives me x squared. X times negative 2 is a negative 2x. All right, then I want to start on my inner. Negative 2 times x is negative 2x. And then finally, negative 2 times negative 2 is a positive 4. Can you go further on that? So definitely. So let me ask y'all this. Here's your like terms. What do you get when you add a negative 2x and a negative 2x? So let's see. Negative 2x's minus 2 more x's would be a total of negative 4 x's. Good job. And then at the end, bring down our plus 4. Maybe you got that in there. I think I'm since I'm on my hot spot, I think I'm lagging just a little bit on this end. Um, but good job. All right, y'all. That would be the final answer on that. And oh, look at this. Now they're throwing some numbers at us on this. So let f of x equal negative 2x plus 4. G of x equal x squared plus 7. They want us to find f of negative 6 plus g of a negative 6. So now they're throwing some numbers at us instead of the variables. So this I could rewrite like this. F plus g of negative 6. Because they're both having a negative 6 put into them. So when they got the same number being put in, you can shorthand it like this. So that's going to equal your F plus your G. Now, y'all be very careful with these negative numbers. When you put them into these x squareds, you got to put them in parentheses of their own, okay? So let's fill it out. For F, I got negative 2 times x, which is negative 6, plus 4. For G, I got x squared. That's going to be negative 6 squared plus 7. You got to put that negative number in parentheses if you're using a calculator, okay? But y'all, I'm just going to work inside both parentheses and do order of operations. Inside the first parentheses, I can multiply. Negative 2 times negative 6 is a positive 12 plus my 4. Over here, negative 6 times negative 6. And y'all, I don't care what number you put in for an x. If it's being squared, it better come out positive. Because a negative times negative makes that a positive 36 plus my 7. So I've only got one move in each of the parentheses. So when I add this, I can drop parentheses. So 12 plus 4 is what? 16 plus 36 plus 7 in the second parentheses. What's that? 43. Everything's out of parentheses. Now I can finally do my final adding. And what do y'all got being? That looks like 59. Perfect. And then 59 would be our final answer. So, y'all, that's the thing on these. You got to go back to, am I adding? When I'm adding, I can't change my variables. Am I multiplying? Well, yes, when I'm multiplying, I can change the variables. Are they giving me numbers? When they give me numbers, I'm just going to follow order of operations. All right, y'all, let's see. This one's got numbers again. Let f of x equal negative 5x plus 13. G of x equals x squared plus 15. So this time they want us to find f of 6 minus g of 6. So a little subtraction here. So since these both have the same numbers, we can write this as f minus g of 6. That's going to equal our f minus our g. All right, so here's f, and it looks like I'm putting a 6 in for the x. So I got negative 5 times 6 plus 13. Over here I got x squared plus 15. So since that's a positive 6, you really don't have to put it in parentheses. You could go 6 squared plus 15. Okay? But y'all, these negative numbers, you got to put them in parentheses when you square them. All right, so I'm going to work in the first parentheses and minus, and then work in the second parentheses. So in the first one, you got to multiply before you add. So negative 5 and 6 is negative 30 plus our 13. In the second one, you got to do the exponent first before you add. So 6 times 6 is 36 plus 15. All right, so once again, I got one move here, add, got one move here, add, so I can drop my parentheses. So y'all, what would y'all put for a negative 30 plus 13? Because these unlike signs give y'all fits sometimes. Oh, y'all doing perfect. That's negative 17, perfect. And then bring down your minus. And then over here I got what, 36 and 15. What's that? 41, 51. Yep. So what do y'all get this? Punch this in and see what y'all get. Negative 17 minus 51. Oh, y'all popping them out quick. Definitely negative 68. So y'all notice this. When they give you numbers to put into them, you're going to end up with a single number. But up here, when they didn't give you no numbers to put in, all you could do was simplify the expression as far as you could go. But when they do give you numbers, you're going to come up with a single number on those, okay? All right, watch this one. Let f of x equal negative 13x plus 16. G of x equal x squared plus 9. They want me to find f of negative 4 times g of a negative 4. So now it looks like they're trying to go through all the operations, right? They did the adding, subtracting. Now they want us to do multiplying. So since they got the same number, I could write this as f times g of a negative 4. Or you could even put the multiply dot in there, either way. So that's going to equal my f times my g. All right, so let's see. For f, we got negative 13 times negative 4 plus our 16. For g, we got x squared. Remember, that's a negative 4, so I'm going to put it in its own parentheses, square it, and then add 9. So we got to work inside the parentheses first. So y'all add multiply that for me. Negative 13 times negative 4. So what do y'all got? 52 plus our 16. Over here we got negative 4 squared. What do y'all get? All right, 16. Good job, y'all. It got to be positive on that. And then add 9. Woo, we're about to get a big number here, don't we? 52 and 16. Woo, that's what, 68? So we get 68. And I'll keep it in parentheses for my multiplying. 16 and 9 is 25. There y'all. So what do y'all need to bring out the calculator? And what are y'all getting? 1,700. There you go. All righty, y'all. So what I do now, let me stop my share for a second. I'm going to pause this and back to the pad. Hey, also looks like we're on number 7 here. So this one's a little bit of division. So we're going to let f of x equal negative 17x plus 7. G of x will equal x squared plus 9. We're going to find f of negative 7 divided by g of a negative 7. So a little bit of division here for us. So they got the same number again. So we're basically finding f divided by g of a negative 7. So when I do my division, I sort of set it up like a fraction. My f on top and my g on the bottom. So on top, I've got negative 17 times negative 7 plus 7. We'll divide that by my g, which is x squared. So that'll be a negative 7 squared plus 9. All right, so when you got fractions, if you was to do this on your calculator, you could either punch it in like a fraction like it looks, and it'll spit out the answer perfectly, okay? So I'll actually pull my calculator up and show you how I would do that on it. All righty, let me pull my chat up because I need y'all to figure out negative 17 times negative 7. Oh, and I'm thinking, what's that? Is that 119? Plus 7. And then on bottom, negative 7 squared would be a positive 49 plus 9. All right, continuing on across, I'm going to add them together. So let's see, 119 and 7 give me 126. 49 and 9 give me 58. So now I need to try to simplify this. Now both of these are even numbers. So since they're both even numbers, I'm going to divide the top and bottom by 2 and see what I get. So 126 divided by 2 gives me 63. 58 divided by 2 gives me a 29. I think at that point, 29 is pretty much a prime number. So I'm pretty sure final answer. But y'all, I'm going to share the calculator and show you how I would punch that in. So I'm going to make it look like a fraction by hitting the green alpha button, y equals, and enter. All right, so on top I had a negative 17 times negative 7, close parentheses, plus 7. On bottom, I'm going to put this in parentheses, negative 7. I'm going to square that, and then plus 9. So it looks exactly like we had it written down. Now, the nice thing about it, if you put it in like this as a fraction, it will give us a reduced fraction answer of 63 over 29. So y'all, your calculator is awesome at doing any of these kind of problems, okay? All right, y'all, so 8 is pretty much the same, so I'm going to skip to 9 here. So it says for the pair of functions, find the indicated sum, difference, product, or quotient. So we're going to find the indicated sum, adding, difference would be subtracting, product would be multiplying, or quotient would be dividing. They're not telling us which one, so they're telling us find f minus g of x when f of x equals 6x minus 8 and g of x equals 4x minus 6. So this one is subtraction, okay? So we got f minus g of x will equal our f minus our g. Then let's put them in. F was 6x minus 8. G was 4x minus 6. Now, when you're subtracting, the biggest issue is to get these two terms right when we bring them out of those parentheses. Because you know, the first parentheses always stays the same. That's going to come out as 6x minus 8. But remember we said on subtraction, we got to distribute that negative. So remember, I treated this like a -1 on that support the other day, or yesterday. So that's like a -1 being multiplied by 4x. So that's going to make that a negative 4x. And then you're multiplying that negative times that -6. Negative times a negative makes that a positive 6. So y'all, the biggest thing on subtraction, I'll tell you what happens a lot of times. People subtract the 4x and then they bring down that -6. But when they're in parentheses, you got to subtract them both. And when you subtract a negative, it becomes a addition, okay? So y'all look at that and tell me, what is my final answer going to be? Does it simplify? Well, Ben, you are like really close, but look at those X's. Now you got me 2x because you're 6x minus 4x got me 2x. And what y'all, Ben and Livy, y'all got it now. -8, +6 is a -2. So we get a 2x minus 2. All right, y'all, so these are sort of going through. Let's try. another subtraction here. So we're going to let f of x equal negative 4x plus 2. G of x is going to equal x squared minus 2. We're going to find g minus f of x. All right, y'all. So we know we're going to have g minus f of x. So I got one function minus another function. But y'all look here, this is reversed. They got the g first. G is my x squared minus 2. F is my negative 4x plus 2. So we're going to drop the first parentheses, and that's going to come out as an x squared minus 2. So y'all, what I want to know, what would y'all put as the next two terms? So what would we finish that line out with? All right, what do y'all got? Plus 4x, good job, and minus 2, perfect, y'all. So we distributed, made that a positive 4x. We distributed, made that a minus 2. All right, y'all, so I'm just going to put them in descending order. The x squared don't have nothing to add to. 4x don't have nothing else to add to. But y'all, add them like terms, and what do you get? Minus 4, perfect. And y'all, that would be our final answer. I'll tell y'all a lot of the biggest mistakes I see on this, people take that negative 2, add to that negative 2, and make it a positive. But y'all remember, like signs are only positive when you're multiplying and dividing, okay? All right, so 11 is pretty much stuff we've done. So let me switch to 12 here. 12 says let f of x equal x squared minus 10. G of x equal 17 minus x. They want us to find f times g of n. So notice, they didn't give me the x here, but they didn't give me a number here either. So let's see what we would do to this. So f times g of a will equal my f times my g. But y'all, here's the question. What would I put into this first parentheses? N for the variable. Good job, Jane. So this N would go in for that X. So that's really going to be a N squared minus 10. Good job. And the same thing with the G, right? That's going to be 17 minus N. Whatever they got into these parentheses is what we're going to replace those variables with, okay? So this is going to be a 17 minus N. And y'all, 2 things times 2 again, we're going to FOIL that. All right, so let's see what we got. N squared times 17 is 17 N squared. N squared times negative N is a negative N cubed. All right, y'all. So now let's do the negative 10. Woo, that's a big number. Negative 10 times 17 is a negative 170. And then that negative 10 times that negative n, negative times negative makes that a positive 10n. Now y'all notice n squared, n cubed, number, n. No like terms. But what we got to do is put this thing in descending order. So the n cubed goes out front and it's negative. So you got a negative n cubed. So to go from biggest exponent down to the number. So next, this 17n squared is positive. So that's a positive 17n squared. Next, plus 10n, good job. And then you got what, a minus 170. Perfect. So remember, although this answer is correct, it wasn't in what they want descending order, okay? All right, also one more of these, and then we sort of change up the questions. All right, so 13, let f of x equal x squared minus 3. G of x, we're going to let it equal 9 minus x. We're going to find f divided by g of negative 2. So basically like the one we did a while ago, f divided by g of negative 2 is going to equal my f on top divided by my g. So I'm putting a negative 2 in for that x squared. So I'm going to have negative 2 squared minus 3. That's our top. And then on bottom, it's going to be 9 minus negative x. Okay. So you're subtracting. So since I'm subtracting a negative, I usually keep the negative number in parentheses on this. And pretty much, I always put negative numbers in parentheses, okay? All right, so let's work the top. Negative 2 times negative 2 is 4. So I get 4 minus 3. On the bottom, 9 minus a negative 2 is like 9 plus 2. And y'all, that is definitely 1 over 11. Good job, Ben. And y'all, that's one of those you could have punched in your calculator like I showed you a while ago. Just remember on the calculator, keep these negative numbers in parentheses, okay? All right, y'all, so watch this next problem they're going to give us. So so these start at 14. So y'all, it says for the functions f and g, determine the domain of the sum, difference, and product of the two functions. So 3 domain problems. They want me to find the domain of the sum, domain of the difference, and the domain of the product. Oh, Ben, I'm gonna get y'all good on them calculators before this class is over. All right, y'all. So for this first one, f of x equals x squared. G of x equals 4x minus 8. Um, so y'all, let me go back to that 13. So I got some that are saying it's a decimal. So let me show you what you would do in that case. So say I punch that one in. Um, Now if you use alpha y equals and enter and use the fraction bars, let's see, let's put in -2, square that, -3, and then on bottom, I get 9 minus -2. Now, if you punch it in like a fraction on the calculator, when you hit enter, it's going to give you 1 over 11. Now, say you was working it out and you did this, 1 divided by 11. And so Marlon, you got this decimal, 0.0909090909. What you want to do to turn any decimal into a fraction, you're going to hit the math button on the left side, hit math. And number 1 says fraction. That means it'll turn your answer into a fraction when we hit enter for that. It brings it on the screen. And then when I hit enter, it'll give you the 1/11th. So you got to sort of physically turn it back into a fraction, okay? All right, y'all. So let me get back to my page where we were at. All right, so we're going to start with the sum, and then we'll do the difference and the product. So the sum is going to be f plus g of x. That's going to equal my f plus my g. Well, y'all, f is x squared. G is 4x minus 8. So the domain of that one. So y'all, what would the domain of this function be if I was adding these two functions? What do you think the domain would be? And there's one question I would ask y'all. Do you see any fractions? So Marlon, you do not see a fraction. So what did we say the domain was if we did not have any fractions? Being perfect. The domain would be x such that x is a real number. No restrictions on that one at all. All righty, let's do the difference. So that'll be f minus g of x. So they'll have you do each one of these three one by one. You'll put in this domain first, and then you'll do the difference. So f minus g will be my f minus my g. So that'll be x squared minus the 4x minus 8. So y'all, give me a domain. All righty, good job. Once again, there's no fractions in this. It's just something being subtracted. So this would be x such that x is a real number. All right, then they said what? Product. That's multiplying. So that's going to be f times g of x, which will be my f times my g. So x squared times 4x minus 8. All right, so for the third one, what is the domain of that one? All right, good job, Marlon. Once again, no fractions, so x such that x is a real number. Now, y'all, 15 is the same instructions, but on 15, they're giving me this. On 15, they're giving me f of x is 1 over x minus 5. G of x equals 7x cubed. So let's start again with the sum. That's going to be adding. So f plus g of x equals my f plus my g. Well, y'all, f is 1 over x minus 5. G is 7x cubed. So for this one, do y'all have any numbers that y'all need to exclude from my domain? Job, you definitely do. There is a fraction right here, y'all. So since I got a fraction, member, I would set x minus 5 equal to 0 and solve that. So what are we going to do? Looks like add 5 to both sides. And you get x is a positive 5. That means we will kick that 5 out of our domain. So that domain would be x such that x is a real number and x cannot equal a positive 5. Okay? So the difference will be f minus g of x. So that's going to equal your f, which is 1 over x minus 5, minus your g, which is 7x cubed. So are y'all kicking any numbers out of that domain? Yeah. And look here, it's the same fraction. So we know that the x cannot equal 5 on that fraction. So this domain is going to be x such that x is a real number and x cannot equal 5. You're going to notice a pattern here. Adding, subtracting, and multiplying all had the same domain here. And look here, your adding, subtracting already have the same domain. So guess what? On this product, you got f times g of x, which equals 1 over x minus 5 times 7x cubed. So for that domain, is it not going to be the same? Because you got the same fraction sitting here. You put a 5 in there. 5 minus 5 is 0. 1 divided by 0 is undefined. And I can't multiply undefined by anything. So look here. Adding, subtracting, and multiplying will always have the same domains. So x such that x is a real number and x cannot equal that positive 5. All right, y'all. So you notice they left out division, but we're going to get division right now, okay? But I just wanted y'all to see that on 14 and 15, all three of those operations have the same domain, okay? All right, so let's try this last problem. So for F and G, determine the domain of F divided by G. They're giving me F of X equals 9X minus 4. G of X equals 4X minus 20. So we're doing F divided by G of X. That's going to equal my F on top, 9X minus 4 over my G, which is 4X minus 20. So this is definitely a fraction because it's division. So the question is, what numbers will I have to exclude from this domain? So y'all, here's the trick on this one. I do not care at all about the front top of that fraction. So Marlon, good job. We're only worried about the denominator. So you're going to set 4x minus 20 equal to 0. We'll solve this for the x, and then that number's getting excluded. I don't care what you got on top. Remember, like I said, 0 on top of a fraction is okay. You just can't have a 0 on the bottom. So you can have 0 pieces of a pie, 1 pie, but you can't have 1 piece of a 0 pie, right? If you got no pie, there's no way to get a piece. That's how sort of I look at them. But here you go. Solve this. We're going to add 20. And y'all look at that. That 4x comes down. 20's canceled on this side. And then over here, 0 plus 20 is 20. And y'all got it, right? X cannot equal 5. Perfect. Because I'm going to divide both sides by 4. And I get X equals 5. So that means we're kicking 5 out. So X such that X is real number. And X cannot equal a positive 5. All right, now y'all got like 2.4 support, but this 2.4 support is just doing foiling and stuff and multiplying, so it shouldn't be too bad. Um, y'all should be able to knock it out pretty good. It just goes with distributing the negatives and stuff. All righty, so do y'all have any questions over today? All right, so let me see. I'm not seeing anything. Let's see. All right, y'all look good on there. So y'all, here's the game plan. We'll stop this recording.